which is what I usually get shouted at about, but I've done that. And let's begin. We spoke last week of user spaces, and in quite a lot of detail, we discussed how you use user spaces. Now we're going to move on to a thing called user indexes. Now, this message, I've just added it right this instant while I was busy thinking about it to make it quite clear that user indexes are not files. They are very different in composition to files. They operate differently. Although they have some common benefits and common capabilities, they are not data files. They are user index objects, and now let us say that a user index is a collection of user spaces. And this is important. This is why I needed to do the user space concept first. Because a user index consists of entries. And each entry can be from 1 to 2,000 bytes long. They can be fixed length or they can be variable length. And the index, the user index, is made up of multiple entries, which you as a user manipulate in exactly the same way using the same code as you do the user space. And that is important. Once you've got a hang of a user space, that method of handling it applies to each entry in a user index. Now, a user index can have, as I said, each entry can be up to 2,000 bytes long, and the total length, maximum size of a user index is 4 terabytes. Now, most of you probably don't have that much disk, so you would never get that big. But they are and can be very big objects. Star USRIDX is the type. Now, when we look at the APIs, because again, this is another type of object that is managed and handled by APIs. You can create a user index using an API. You can add entries to that user index. There's an API to allow you to do that. You can retrieve user index entries from the user index. Now, you can also remove user index entries. Now, these last two might look very similar, but actually, the first one is a non-destructive read of an entry. So you can retrieve the entry and leave it in the index, which is a non-destructive read. So you can always reread that index should you wish to do so. The remove of the user index is a destructive read. It's read and remove. So those are the 4 APIs that allow you to drive the user index. The delete user index and the retrieve user index attributes are seldom used because, of course, in most cases, this is built into the QTemp library and therefore is recovered when the job ends without too much of a problem. The other big difference between user indexes and user spaces is a user space has a pointer to the first byte of that space, and you can retrieve that pointer and base all your activity on that pointer. A user index is not identified by pointer. It is identified throughout its use by its name and library. So identifying it is by name and library and not by pointer. However, you can still use pointers to manipulate an entry. That's not a problem. We will look at that. Right, so what we need to do is we need actually, and I thought I had it somewhere, but Yes, I did. We need just to look at the APIs, create user index APIs. So I'd like to just look at them. They are object APIs. And if I can find them, user space. They're here somewhere, I know, because I've seen them before. There they are. User index APIs. The first thing one has to do when you wish to use a user index is you have to create one. So let's have a look at the create user index. Now, you can see from looking at this list of parameters that this API has actually undergone significant updates. It's got 4 optional parameter groups, so it has had significant modification made to it in the past. This is a good way of indicating that it's actually used quite a lot. Now, the required parameter group is 10 parameters long, and optional parameter group 1 is generally used as the replace indicator. So when you create, you can replace, and the error code indicator. I have never used optional parameter group 2, 3, or 4. So let's go through the parameters and just understand what we need to give this API in order to create the index. Because the definition of the parameters will define how this index is going to behave. Okay, if it's bigger than 4 gig, it can't be saved prior to release 5.2. I hope there's nobody still on 5.1 because that would be awkward. Right, let's have a look at the required parameter group. Qualified user index name. It's a standard API qualified name. The first 10 characters are the library. The first 10 characters are the name of the index, and the second 10 characters contain the library name. And you can use only one special value for the library name, and that's current library. But typically, most of the time, these indexes are stored in QTemp. However, if you want an index to pass information from one job to another, then you're going to have to keep it in another library, in which case you've either got to hard code that library or set it as current library before you create the index. Extended attribute is just the same as the extended attribute that we had on the user space. It's simply the type is star USRIDX, and you can give it an extended attribute, a physical or any other type of extended attribute. Must be a valid name, but other than that, you can do what you like with it. Right. Here is the first of the parameters that define how your user index is going to behave. You can specify here in one character whether there are fixed or variable length entries for the user index. F is fixed, strangely enough, and V is variable. Who would have guessed that? A fixed length entry is always of the same length. It has X number of entries. The number of entries, you can choose how many you add in, but they're always all of the same length. A variable length entry, you specify when you add the entry into the index, you specify how long it's going to be. Once again, with this particular code that's going on behind the scenes here, I'm amazed at the capability of this thing and the efficiency with which it works. Right, here we specify the entry length. It's valid for fixed length entries from 1 through 2000. It's valid for variable length entries. Its valid values for variable length entries are 0 or -1. A value of 0 here enables a maximum variable entry length of 120 bytes and of a key length of from 1 through 120, i.e. the whole key, the whole record, the whole entry can be the key. By the way, I'm going to try and refrain from using the word record. It's an entry in an index because otherwise it sounds too familiar. A value of -1 enables a maximum entry length of 2000 and a key length from 1 through 2000. So this entry length does quite a few things. It says, do I have a fixed length entry? And if I do, how long is it? And do I have a variable length entry? And then it sets a maximum for a variable length to either 120 or 2000. All right. So that is the entry length, which is a parameter on create. Key insertion. Whether the inserts to the index are by key. 0 says no insertion by key, and 1 is insert by key. Now, an insertion by key means it's going to be placed into the index in key sequence. So when you're writing an index, if you're inserting by key, you can write the index and it will insert, it doesn't sort the index. This is an important thing to understand. This is why it's so efficient. It doesn't sort the index, it places the entry into the index in the right place. Okay. Now, concept of key length. If you're doing key insertion, you need to specify key length. The length of the key, where the first byte of an entry is the beginning of the key for the index entry. So understand carefully here that the key starts at byte 1, i.e. there's no start position for the key. The key begins at byte 1. So you have to construct your entry. You construct your key first, beginning from the left-handmost byte, and you construct your key to build what you want as a key. Then the balance of that after the key length can be anything you want to put in there. It's defined by data structure, manipulated by pointers. You can do anything you like with the space. So you have a key section up front, and you have a data section at the back. Interesting part about this is the value for this parameter must be 0 if you have no insertion by key. And you can specify a key length up to the maximum entry length of 2000. Which means, in fact, that the whole entry is the key. It's not a file. If you specify a key length, that is the piece of the entry that is used to sequence where it is placed in the index. It's a number of bytes. If you want to get very fancy, and I've done it once or twice, but I've confused myself utterly. Your keys do not have to be constructed with the same fields for every entry. You can manipulate the key fields and the values to give yourself whatever keys you want to give it. But it's a once-off. There's no logical view. You can't look at these entries by an alternative key. You'll see later. You can look at it using a shorter key, but you can't have a logical view over it because, as I said earlier, it is not a file. All right. So you specify the length of the key. Now, when you're building an index and you're playing with this thing and you wanted to do something specific, it might be a good idea just at the beginning to give yourself a bit more key length than you actually think you're going to need, because you can always move that around. Doesn't matter. You can always change it. So it's the establishment of the key that is the power behind the sequential processing of a user index. If you have it non-keyed, of course, it puts it in arrival sequence, and you can read it. We'll have a look at that. We'll see how you can read it when you actually retrieve the entries. Immediate update, the next parameter. If you set no immediate update, it keeps the parts of the index in auxiliary in memory, and it writes it to auxiliary storage when there's resources available to do so. If you say immediate update, it means that the updates on the index are written immediately to auxiliary storage. That means it's written to disk on each update. Now, depending on how you're using this index and what you are using it for, it's probably, I use an immediate update as a matter of course to make sure that I don't lose entries. But depending on how you use it, a no immediate update is probably more efficient, works faster, because it only does the updates to disk when it can manage to do so. All right, optimization. The type of access in which to optimize the index. This is, of course, if you're using a key. The type of access, the valid values are 0, optimized for random references, and this one is optimized for sequential references. To be absolutely honest with you, I've tried both on the same index, and the differences are not measurable. It probably has an effect if you have large keys and a large number of entries in your indexes, but I've never noticed any difference whether I optimize for random or sequential. I usually, in most cases, when I'm processing indexes, if I'm loading them randomly and reading them out as key sequence, I optimize for sequential. But I don't know what difference it makes. There's not much documentation on the subject of what effect it actually has. So I tend to optimize for sequential if I'm going to process it sequentially, or optimize for random if I'm going to go all over the place with it. Public authority, logically, this is the normal public authority for any object on the system. You can give it the authority that you want at the time you create it. The typical one here is all. And here's a text description. Not really. I don't really bother to use it when I'm building in QTemp, because the name is all I need there. But if I'm building it to pass to store data, which I can do, or pass data from one job to another, then usually a text description is a very good idea. Right, let's have a look at the first optional parameter group. Simply whether you want to replace an existing user index, which means an index with the same name in the same library, no or yes. There's a lot of, the new user index is subject to the same authorities. The user index being replaced is destroyed if both. So otherwise it moves it into the replace object library very similarly to a program. And then, of course, you have your error code, which is a standard error code structure. It's a normal API error code structure, which returns information about errors that have occurred during the call to the API. The domain is either system or user or default, and it depends entirely on this table. I've never bothered to define this one. Usage tracking. The default here, if it's not used, is 0. Do not track the usage state. 1 is track the usage state, but I do not clearly understand. There's machine checkpoints to improve availability of user indexes. Never come across it, never had any need to use it. And of course, index size option. Here is, it's 1 terabyte. The maximum size of the user index. Maximum size of a user index by default is 4 gigabyte. If you use this parameter and put a 1 in it when you create the user index, you get a 1 terabyte user index, which is pretty big. It's pretty big. Let me tell you, you can get a lot of information in there. So, by the way, user indexes are also very useful for your display file subfiles. You can load them up very fast, and you can move around them all over the place, up and down, and read sections of the index, and you can load them, and they will change their sequence as you load them. So it can be used quite effectively for display file subfiles. Okay, so that is the create function of a user index. That's the first one, and obviously I want to now show you quickly create user index. Again, like everything else that I do with these APIs, is I've wrapped them in a little service procedure. And so I can now reduce the number of parameters and standardize on a lot of things. This is your create user index API, and in fact all the optional parameters are defined. Here is the prototype. The procedure is called create UI, user index name, entry length, and key length. That's the one. This one here, which now conforms to the standard that I mentioned to you about naming conventions for APIs, is a create UI for a variable length. This one was a create UI for fixed length. This one is a create UI for variable length. Notice the entry length parameter is not there. Okay, so this particular procedure has a create for both fixed and variable length. And a lot of the parameters here are standardized. Here's the create UI. UI I put on qtemp to get a index name. There's the index name. No attribute, fixed length, entry length. I can't even remember what all of these are. Fixed length, entry length. Key insert is a 1 there. Key length there. The naught is update immediate. I've got it as naught. Optimize for sequential is a 1. Public authority star, all, nothing for text, replace yes, and error code. So I just have to pass it 3 parameters. Those are the ones that need to vary. The user index, the variable one, is very similar. V for variable, -1. I think that's the 2000 byte. And so on and so forth. All the parameters are provided. And the only thing we have to specify for variable length is the key length. And all entries have to be at least as long as the key length. Can be longer, they can't be shorter. Otherwise, you get a problem with variable length entries. Now, these have been prepared for open source distribution. But please understand, these are my two, and I use them all the time. But I use them as they are here. You have to look carefully at these parameters and decide, are they good enough for you, or do you want to add procedures to create user indexes? Right, looking at the next one, how do you actually populate a user index? You use the API called add user indexes, add user index entries, and that is what you use to populate the user index. So let's start by getting back to add user index entries. There it is there. Now, the first two parameters are returned parameters. When you use this, it returns the library name that it actually found that user index in. That's typically because you might qualify the user index name with star library list. So it returns and says which library it found the library list in. It also returns you the number of entries that have been added. And this is an interesting thing because you can use this add user index entries to add multiple entries at the same time. You can add blocks of entries. You can add 300 entries. It's quite nice when you're adding records from a file, because you can read 300 records and you can put them in a block and you can add them as a block to a user index entry. Here is your qualified user index name. It's your name and library. Let us go down to the detailed definitions of the parameters. There is your returned library name. And there is the number of entries added. The number of entries successfully added to the specified user index. If an error is received while processing the entries, this number indicates how many were added before the error occurred. I.e., if you're adding multiples and you have an error, it'll tell you, I added 10 of your 20 that you asked for. Right. Again, the qualified index name. The first 10 characters is the index name. So basically, the index is dealt with by name, not by pointer. And the second 10 characters contain the library name. Right, insert type. And this is a key. This is really the important part of how you're inserting a keyed entry. If the entry is unkeyed, if you've created an unkeyed, this doesn't really apply. One is you are planning to insert a unique argument. This value is only valid for non-keyed user indexes. If the entry is already in the index or the index entries are keyed, an error is returned. To be honest with you, I've never used this. Does sound a little kinky. It's only valid for non-keyed user index entries. What it probably means, if my understanding of the API is correct, is that a duplicate entry, i.e., where the entire entry, unkeyed entry, has been duplicated, it will throw it out. An error will be returned to say, I already have this entry in my index. And that will be a binary match front to back. Insert with replacement. It requests to replace the non-key portion of the index entry if the key is already in the user index. It is only valid for keyed indexes. If the entry does not exist, it will be inserted. If the index entries are non-keyed, an error is returned. So what this is simply is an update. You specify the key portion, and you specify a non-key portion. If it exists, it will update the non-key portion. If it doesn't exist, it will insert the whole entry. So it's an update or insert, if not found. By the way, it is from this that I devised that action code of UI for my input-output servers to say update non-keyed portion or insert if it's not there. It came directly from this particular behavior of the user index. Insert without replacement. This value requests to insert the entry only if the key is not already in the user index. It is valid for a keyed user index only. If the entry does not exist, it will be inserted. If the entry is already in the index or the entries are non-keyed, an error is returned. So that's a insert without replacement. Now, I do have a question which came from Kay at Everett relating to something that she's trying to do, or one of her people is trying to do. And as you can see from what we've just discussed, you have to have a unique key. So far, we have a user index which can't really have a duplicate. The keyed portion is X number of bytes from the front. And if you want a duplicate, you can't have a duplicate key with different non-key portion of the entry. So the question is there a way around? The answer is there's always a way around. We'll find one. There's a trick that I use for this, to do this type of thing, that works very well and is absolutely of a simple thing to apply. Right. Then let's have a look at the index entries. An index entry is a variable character. Obviously, it depends. If you've chosen to use variable indexes, then this is a variable length. If you're using fixed indexes, this will be the length of the variable portion of, actually it won't. It will be the total length of the entry, including the key. In fact, this is the actual entry. The first portion is the key, and thereafter you've got the non-keyed portion of the entry. And that is it. If you're working with fixed length, it's obviously a fixed length. It is the entry. And you populate it with values. It's recommended that this parameter should be the same length as the length of index entry parameter if you are using fixed length. Length of the index entries. That is the length of the index entry itself and is used in combination with, or used when you're dealing with variable length entries. Obviously, the length of the index entry must be greater than 0, and it must be equal to the length of fixed length entries. Now, entry lengths and entry offsets. This is a particular structure which you use to specify an array of entries that you wish to add to an index, i.e. a block of entries. Now, I'm going to be upfront honest with you. I've never done this. because I have never read a block of entries that I needed to add to an index all in one go. So I've never used it. But I would imagine that this can provide a lot of functionality when you are doing sets processing from SQL. Because when you're doing sets processing, you're basically picking up an entire set of records. You can then take that entire set of records and plonk it into an index in one operation, which has got to be quicker than doing it one at a time. But I have never personally used it. Format for entry lengths and entry offsets. Let's just have a look at, here's the little record. It's very simple. The following table defines the format for the entry lengths and entry offsets parameter. So this must be a structure which has two fields in it. One is the length of the entry you're adding, and the second is the offset, number of bytes from the entry buffer. Now, let's go scroll back here. Index entries here can be a data structure, could be anything. It's a block of bytes. And that index entries could contain more than one index entry, i.e., you could load that structure with 50 index entries of 2,000 bytes. Then your entry lengths and entry offsets array would point to a structure which had the entry length, the first entry, 2,000 bytes. The first offset would be 0. And the following fields will be repeated. The number of times they are repeated depends on the value specified in the number of entries parameter. So if you're going to add 50 entries, you would have 50 pairs of these fields in a data structure, providing the length and the offset for each entry in your buffer. It's pretty much only necessary when you're using variable length records. However, in order to standardize, even if you're using fixed length records, if you want to add more than one record or one entry to the index, you have to use this little array. And obviously, you have to build it up. But it's easy to calculate if your entry length is fixed, because the first offset is 0, the second offset is 967, and then the third one is, and so you just simply add the length, and so on and so forth. If I've confused anybody, please send me a message and tell me to stop and do it again. Number of entries, and you specify here the number of entries that you want to add to the index. Now, as I've said to you, I usually don't add multiple entries to an index. There's some I can understand and I can appreciate there are possibilities and there are reasons why one would want to do that. And the API allows you to do it, which means that if you need to do it, it's definitely going to be more efficient. So this one I can't give you any guidelines on, but it will work. I know it works because these APIs do work very well. So that's it. That's the add of an entry. And the secret is how you design your key for your entry. Now let me just go to the API. This is a module for add user index entries, and there are only 2 of them. Add a user index entry variable length. Add a unique user index entry for a variable length. There are others. Or there should be others. No, they're not. I've actually, this is all I use. There's the Add User Index API. Number added, then I've got the user index. 2 is the insert. There's the entry. And if you'll notice, the entry here is 32,767. But I have an entry length. And this is based on an entry pointer. So here is where you see the pointer coming into play as a parameter on the call. The pointer then points to this entry that is being added to the index, or the block of entries that's being added to the index. Entry length comes from the add, and the 1 is the number of entries. This one is set up to add 1 entry and 1 entry only. And this particular one is an add user index entry for a fixed length, and this one is add user index entry for a variable length. And as you can see, this one has the entry pointer, i.e. a pointer to where the entry can be found, and this is the entry length, because this is the variable entry. This one is got exactly the same parameters, because you still need the entry length in the call to the API, even if it is a fixed entry. So you build your entry. Let me see if I can find the code that I had the other day. Building an entry. This is the code we use to examine the user space. But if you remember, we have a user entry. Yeah? And we have a pointer to that user entry. This user entry is based on that pointer, which we programmatically sort out. Now, if I have an entry which is not based on a pointer, I can pass that pointer of that data structure or that entry to the add user index entry. So again, it's pointer based. Your entry can be in the program, and you pass the pointer to that entry to the API. Okay. Are there any questions at this point? Just want to make sure, because I've been throwing pointers and entries and bits and pieces around all over the place. Okay. As long as you're all still with me. Right, let's move on to have a look at the retrieve and remove, because these two are pretty much identical in terms of the process. and the parameters. The only real difference is one leaves the entry behind and the other one takes it away. So let's have a look at the retrieve user index entries. There it is there. Right. Well, let's go down to the detail one. It's easier to work with this one. Required parameter group, receiver variable. This receiver variable you need to make available. You'll notice it's an output. So what is going to happen is you're going to pass it in to the API, and the API is going to populate it with the entry or entries that it has received or retrieved for you. Okay, so this is a variable that is to receive the information requested. You can specify the size of this area to be smaller than the format requested as long as you specify the length parameter correctly. So you need to specify a space into which the entries are going to be retrieved, and you have to specify the length of that receiver variable so that the API knows how much to put into that receiver. Now, typically, if you have a 2,000 character entry, then your receiver variable will be 2,000 characters long, and your length of the receiver variable will be 2,000 if you're retrieving one entry at a time, or multiples. It gets a little more complex if you're using variable length entries in your API. And the variable length entries are handled in exactly the same way as they are when you add them. Entry lengths and entry offsets. But in this case, this array is exactly the same as the one you used to add the entry, but this is an output, i.e. the API puts into this array for each entry its entry length and entry offset. But before the first entry of that, you will get two fields called bytes returned, and bytes available. These are two very, very important fields within the API processing. An API that's returning you information will always tell you how many bytes it actually sent you, bytes returned, and how many bytes there are available to be returned. They're two integers, and they always sit right at the top of any structure. So this one here, you will see them here in the structure for entry lengths and entry offsets. First two fields are bytes returned and bytes available. If these two fields are equal, it means you've got everything that you asked for. If they're not equal, you may or may not want to retrieve again or something like that. Very important pieces of information to tell you whether you've got everything that the API has to offer. And you'll come across these two fields in a lot of APIs, particularly list APIs and retrieve type APIs for information. They will always tell you how many bytes there are returned based on your length of your receiver variable. Bytes returned will be the length of your receiver variable. Bytes available will be either equal to or bigger than your bytes returned. Number of entries returned. There's your for loop control. Its output, it comes back from the API, and it is the total number of index entries that found that satisfy the search criteria. And this is one of the powers within the actual API, is you can search by criteria, and it will return all the fields, all the entries that match a particular criteria, a search criteria. So you can populate your index without a key, and you can search for particular entries based on values in the record. It also returns the library name it found the index in. Obviously, you have to provide it as an input with the name, the qualified user index name, and the format that you want the information returned in. Now, in this particular case, there is only one format. We talked about multiple different formats for the return of information from an API, but in this case, you get only one. You can also limit it, maximum number of entries returned. If you are doing that to match a search criteria, you can say, well, I only want 50 entries returned that match this criteria. Although the valid values are up to 4095, you can return a block of 4095 entries as a maximum that match the criteria. Right. Search type and search criteria. So let's just look at the types of searches we can do, and then we'll look at the criteria that we can use to search. We can search for equal condition, i.e. find all the entries that are equal to the search criteria. We can find entries that are greater than the search criteria, less than the search criteria, greater than equal, less than equal. We can also look for the first entry. We can look for the last entry, and we can look for entries in between two specified search arguments. Now, okay, this may also be a way of solving your requirement, is to actually use a search and pick up all the, i.e. don't specify the key, but search based on the key, and pick up all the entries that match that key. We'd have to look at your requirement a little bit more detail. Okay, search criteria is a variable length character input field. If the search type is 8, both search elements must have the same length. When the search type is 8, this parameter contains two search elements. The first element is considered the starting element, and the second element is the ending element. So only when the search type is 8 does this search criteria have two entries. All the other searches, it has a single entry, except where it's a first or last, in which case it is ignored. Makes complete sense, and when you look at this, you think, it's easy stuff. Please practice and play with it, because it's not quite as easy as it looks. You've got to get all the ducks neatly lined up in a row. Length of the search criteria. You specify the length you are providing of the search criteria. If the search type is 8, this parameter specifies the length of the first element. The second element must have the same length as the first. Valid values are 1 to 2,000, depending on how the user index was created. So here you can actually search on the entire index entry if you want to. For fixed and keyed user indexes, the length of the search criteria can be greater than the length of the key, must be less than or equal to the entry length, i.e., you can search on information that is greater than the length of the key. Search criteria offset. This here is an input binary integer, which is the offset of the second search element from the beginning of the search criteria parameter. This parameter is ignored unless the search type is 8, i.e. this basically is the length of the search criteria, and this should actually equal the length of the search criteria because it's the offset to the second element in the search criteria. Never understood why those two both search elements need to be the same length, and yet they're asking you for the length of the search criteria here. And again, the offset when they could calculate it. Okay. Format, i.e. this is the format IDXE 0100 is the format of the returned entry. It's not very complicated. Remember, you can get multiple of these coming back if you are receiving more than one entry. So the first 4 bytes integer are the bytes returned. The next are the bytes that are available, i.e. if you ask for a particular search criteria and you find 3,000 entries, but you've only asked for 50. You will get bytes returned showing 3,000 times the length, but the bytes available will be very much bigger than that. So here you can determine whether you have got more or less than you are expecting. And then here, this is the offset 8, 0, 4, and 8. This is where the entry actually begins, or the entries begin. Entry 1 to N. It's just a long string. And you use this entry length and entry offset in this parameter, format for entry lengths and entry offsets. You use this to unpack this long character string, which can contain 1 or more entries. Now, when you're working with a single entry, it's very easy. When you're working with multiple entries, you just got to have your wits about you and understand that you are working with pointers and offsets, i.e. you would set your pointer to the beginning of this format. Add 8 to step over those 2. And that means your pointer would be pointing at the beginning of your first entry. When you want to get to the second entry, you would add the entry offset of the first entry to your pointer, which would then take you to your second entry, and so on and so forth. So you would process these 2 fields using a for loop based on the number of entries. And you would be then processing your entries based on that for loop and the entry offset that you add to the pointer that you are moving down the buffer. You could, of course, then base your data structure, which described your entry. You could base that data structure on the pointer that you're moving down the structure. Let's have a look at the code. Retrieve user index entry. This is the API again that I use, and I process only single entries. So retrieve, I have one that says retrieve user index entry. That's the first procedure. It has the name of the user index. It has the entry pointer, i.e., in this case, it's the pointer to the structure I want to put the entry into. It has an entry length and a key length. Remember, the key length is from byte 1 of the entry for a length of the key length. I have a retrieve next user index entry, which retrieves the one following the last call that I made. This one is retrieve first user index entry. And then I have a retrieve user index entry for variable length, next for variable length, and first for variable length. So I have created those, and you will notice that the last three were added to this service program when I started using variable length indexes. Up until then, I only needed the first three. But then I started using variable length indexes and therefore had to create additional APIs within my service program. Let's have a look at this retrieve user index entry. This one will retrieve, and if you look at the parameters, and I'm going to just use the double X's here. Okay. This is the API. Here, there's the receiver variable, RV. That's where I wanted to put the entry in. That's the length of the RV. Now, RV, where did I set it up? Sorry, I'm just looking. It should be here somewhere. There it is there. RV has a integer, bytes returned, bytes available, and an entry of 2,000 bytes. I made it long. The RV is 2008. I'm planning to receive a single entry of whatever the entry length happens to be, up to a maximum of 2,000 bytes. But remember, this is a fixed length processing. So ELO is the entry length offset, which I have to have. Bytes returned, bytes available, entry length, and entry offset. So that is in relation to the RV, which is the receiver variable. And it's based there. So the entry length will be whatever the length of the entry is that I'm using. And the entry offset will generally be 0, because it will be the first entry in the array, because I'm only bringing back one entry. 16 here is the number, is the length of the ELO. The ELO length is 4 integers, so it's 16 bytes. Number of entries is there. That will tell me how many entries it has returned. You can see that the number of entries doesn't have a constant, therefore it is a return variable. LR, what's that one? Library returned. There's the name which it's going to use. There's the format which we talked about as being the only format. Maximum number of entries is 1. Search type is 1, i.e. this is a search type where I'm saying I'm looking for an equal condition. And this is the search criteria here. So you retrieve out or receive out of a user index by a search criteria. Now, I want to provide a key and go fetch that key. So I'm looking for an equal condition for the key. So I set up the key. And then the key, the search criteria is actually the entry starting from position 1 for the key length that is provided by this parameter. That is the search criteria. The length of the search criteria is the key length. So this really is a simple procedure to fetch an entry which matches a key that I've already put in to the receiver variable. I've put the key in there. So I've put the key into, sorry, not the key, where's it based? Entry pointer. Where's the entry pointer? Right. The entry pointer is pointing to the space in my program that contains the buffer that the information is going to be returned to. So I'm using the key, I'm fetching equal to a key. That's essentially what I'm doing. The search criteria offset is 0. Because I'm using the key, I'm searching from byte 1 or offset 0. So this is a simple retrieve of an index entry based on a key that I give it. Now, if we have a look at the difference between the retrieve based on the key, which is this one, and the retrieve next, you will see that the only difference is that there. I.e., this one is a 1 which says equal to the key. 2, if I can find it, is a greater than condition. So if I set up a key at the pointer and retrieve the index entry that equals that key, I will get an entry that equals that key. If I then want the next entry all I have to do is call this API, because it'll pick up the next record that is greater than the key that I had there previously. And this is how you read an index. You set up a key and read it equal, or you read next. It's all based on the key that you have set up in your entry structure. Now, you're going to have to play with this a little bit. You've got to play with it. You've got to get used to it. And you can take my APIs. These I will publish in the open source before the end of the week, because they are now ready to go. And this one here is retrieve the first. Notice this one is set to a value of 6, which retrieves the first index entry. And this one is a specific retrieve on 1. And then, but this is for variable length. This is the next record for variable length. And this is the first record for variable length. So if you wanted to read your index in sequence, fixed length index in sequence, you would use that API to read the first index entry. And of course, that would populate your structure, your whatever entry structure you have in your program. It would populate it with the first entry in the index. Subsequent entries, you would simply use this one. And each time you called that, you would receive the next record. The only thing you've got to watch out for, and this is why I bury this thing in its own APIs, is there's no automatic end of file indicator like there used to be, or there is with files. You have to manage your own end of file indicator. And the way I've achieved that in all of these APIs, they all have a Boolean return indicator. So in this particular case, retrieving the next API, I test if the number of entries is 0, return an off, which says that I didn't find an entry. Otherwise, take the entry and move it, substring it into entry, this one here, for 1 for entry length. And of course, that's based on the entry pointer that you sent in. So you are then taking the received entry and putting it into the target structure, switching on the return indicator and returning control to the caller. So what this is, this piece of code here is in fact an end of file control or a return of a received entry. It's not a file. It works differently from a file. And you've got to understand that. It is fast. It is very fast. It's much faster than a file. But it has its limitations. You can only process on the key you've planned for it or longer. You can't process a different key. You can start lower down the key and process for longer, but as you can see, that sometimes not going to be very easy to work out. But it is very fast. Now, the remove, that was the retrieve. A retrieve will fetch the entry, make it available. Please, before you start using these things, take this open source and work through it step at a time. Just to make sure you understand what this procedure is actually doing to make the entries available or to add the entries or to whatever. If you look at the remove user index entry, you will find that it looks identical. Remove user index entry, remove next. Clear user index. There's one that says clear user index. Remove user index entry, variable length, first, and so on. There are a number of procedures in here. And yes, they were written at a different time, so the naming convention is not actually exactly the same, which is probably not good from a standards perspective. But you will see the structure looks exactly the same. If we take that one and we put it over there, and we look at this one, there we are, retrieve and remove. You can actually see that it is very, very similar. Identical, in fact. The only difference, it uses the remove API instead of the retrieve API. So after you've called this particular API in the remove UIE, the entry is no longer in the index. And that is why we added into this index the clear function to remove all user indexes, all entries from a particular user index. And basically 4095 and replace them. That actually just cleans out 4095 entries out of the index. The key is actually blanks. There's the key there. It's a binary 0 in the first byte. So it removes everything that's greater than that. So I've added different procedures into these APIs to simplify the use. The longest parameter list is user index, entry pointer, that's pointing to the structure containing the entry or the key, the entry length and the key length. Of course, if I use unkeyed, I don't need a key length. So user indexes have many uses. Data areas, data queues, they are much faster, much more flexible, and much bigger than data queues. You can use them to store many records. You can sequence automatically on add. Unfortunately, I could sit here and I could rattle off probably dozens of uses for user indexes. And my choice when I'm looking for objects to do store, pass on information, or actually collect information for a later program or something like that, it's user spaces or user indexes. I don't use data areas anymore. I don't even use the local data area anymore because it's too small. It's only 1K. Data queues I don't use. Data areas, none of that stuff. Because user indexes, user spaces are so much faster and so much more versatile, and you can make them permanent objects. They can be put into a library and they can become a permanent object and become part of your backup. So you can keep track. You can log stuff on it. I think that was something, Kay, that you were mentioning. What were you trying to do?
On the, I think what he was trying to do is that he's putting stuff in the user index. He does have a duplicate key, not a unique key.
Yeah. Okay.
But he's needing to pull it down in a sorted fashion.
Okay, but does it matter in which order the duplicates come in?
I would have to ask him. I'm not sure.
Okay, because I have a technique that I use to handle that is right at the end of the key, before the non-keyed portion of the entry, I put a sequence number, usually an integer sequence number, unsigned integer, which gives you 64,000 or something, 64,000 entries. I put that right at the end of the key. And I simply increment it by 1 for every single record that I add to that index. Now that means that if you search by the key minus that number, you can collect all your duplicates. But the duplicates will be in arrival sequence, because that's the way they've been sorted when you added them. So that's pretty much when you're working with a non-unique key, the non-unique portion is going to be in arrival sequence. There's no other way you can sequence it. So that you'll have to see whether that provides a solution. The question there is definitely, do you want the duplicates in arrival sequence? You then add that extra number to the end of the key to make it unique so the duplicates can be added to the file as unique keys, because otherwise you're going to simply update the last one with the previous one with the current one. So you need to make it unique, and the simple way of making the key unique is simply to add a sequence number to the back of the key. When you select equal to the key, you will be getting them in the same order in which you added them to the index. Okay. Now, this has probably left you with slight confusions. User indexes are a different animal. They are not files. But they can be, and I have used them incredibly effectively in many, many circumstances. For example, just let me give you an example straight out of AO itself. While I'm processing a file, let me see if I can just pull one up quickly, just to give you an image. We'll pick up let's just take CusBal F and look at its format. Now, these are the columns in the customer balances file. Now, if sorry, let me just fix that, because I've got totally the wrong thing here. I didn't want to show you that. I want to show you the logicals, and I want to pick up this logical here. TDS join, format definition. Right. This is now a explicit join file, because join files are by definition explicit, because you have to specify the fields, because your format is different from any one of the physical files. So it's an explicit definition for a join file. You can't get away from that. However, if I wanted to either remove or add one, or remove one of the files, or add one of these files, another file to this join, I would have to refresh the explicit definition and reload all the fields in the file. So what I do, just to save an awful lot of time and trouble inside the code, is I simply delete all the fields and then repopulate them from the list of files that you find here. However, if I did that, I would lose the keys, which are held on another file, because I've got a cascade delete. So when I delete the fields, I will, by cascade, deleting the keys. All I did to resolve this problem was to create a user index. And before I did a delete on the fields, I simply loaded the keys into the index. They were just, I picked up the record exactly as it was, and I loaded it into the index. So the index now contains the keys for that file. I can then repopulate the field file and from the user index repopulate the keys file. But if one of the keys won't populate because of the constraint, then I can just drop it, because it means the repopulation of the field lost one of the keys. So by using an index, I'm using it as a temporary key storage for this process of refreshing the columns and then putting it back afterwards. That's one simple use of it. There are plenty of others. It's also goes along with the joins. You've got joins in this file. The same thing happens here. When you delete the fields, you will lose the joins. I do the same thing to store the joins and put them back again afterwards. That's a very powerful use of indexes, and it's quick. Very, very quick. Indexes are very quick. So it's really limited to your understanding of their abilities, which I'm afraid I can talk until the cows come home, and it's not going to change your understanding, your total understanding of index APIs and indexes, user indexes at all. The only way that you are going to come to grips with this is to actually find something like Kay and her people are doing, and that is appropriate, and actually work with it until you get it to work. Try different things. Even if you cook up something that's really not impractical, but that is a good exercise that you may be able to use in the future. A lot of enterprise services could use user indexes to pass information from one part of the job to another. There are an endless number of possibilities. All I'm trying to stress here is they are not horrifying. They do work, and they can give you an incredible amount of power and functionality, particularly if you wrap them up into service programs to make them easy to use. Okay, I'm going to move on unless there are any questions, because we've got about 20 minutes, which is perfect. There's a few things that I want to talk about, which will take us to whenever it's supposed to take us to, 6 o'clock. And then next week, sorry, not next week, it'll be Thursday, I will start the session and I will introduce Nathan to you, and he will then use 4 sessions to introduce you to a front-end development tool called OnePoint Portal, which I think is going to impress you no end. But that comes Thursday, and I can sit and listen and not talk, which I will be very happy with. I'm sure all you guys have had enough of my voice by now. Let's move on. Built-in functions. Now, I'm not going to go into every one of the built-in functions. Never. not at all. Built-in functions are your business. You must scroll through. I don't know if you're on version 7.2, 7.1, 7, I don't know what versions we're on. Go into your RPG ILE reference manual, operations, expressions, and built-in functions. Operations. Scroll through the operations, please. Just make sure they haven't snuck one in. There's one, sort A, that came in at 7. The hash, by the way, indicates that it came in at 7. What am I looking at? 7 point. I'm looking at 7.2. So the hash indicates that it was 7.1 that was introduced. 7.1, 7.1. A bar indicates it was introduced in 7.2. So please, every time you move up a release or you get a technology refresh, please do this exercise. Scroll through the opcodes just to make sure that they haven't snuck one in. Because I know the one they snuck in at 7.1 was, no, it was in a built-in. There are your expressions. Have a look at those. Make sure they haven't snuck in a bunch, but it's the built-in functions that are interesting. Going through the built-in functions. Read them. Understand what they can do for you, and try and park them away in the back of your mind so that when you have a task to perform, a built-in function, there are a lot of them now. There are more now than there have ever been. And sometimes they change. I mean, you've got the date built-in functions. Dec is a way of changing characters to decimals, or date timestamps to characters, to decimals rather. Go through these. It's good bedtime reading. Look, there's a bar which indicates that this release has brought out something new. Look for these bars and have a look and see what new has become available, because they can actually help you a lot. And it gives you a basis on which you can start using the newer functionality as it becomes available. So the bars indicate the current release, and the hashes indicate the previous release. Decades, difference between two dates. Between two dates, 2 times or 2 timestamp values. A simple single function that we used to have an incredible amount of difficulty dealing with in the old days. Just go through them. Obviously, things like equal, end of file. Here's one that says get the number of elements from a table or an array, or a multiple occurrence data structure, can be very useful. I'm just looking to see whether I'm working mainly on 6.1 because that's where AOistic, and I'm just looking to see whether anything has snuck in under my nose. Okay, you've got palms, which were all on the previous release. Palms returns a number of parameters that were passed to the procedure in which palms is used. For cycle main, palms is the same as star palms. So there is a reference to cycle main. There must be something different with linear main, which we talked about before. So you do need to do this. Then palm number. is brand new. Marinus has asked, aren't we now on V2, not 6.1? Yes, we are on V2, not 6.1, but I'm coding for 6.1. So I can't use any of these fancy V7.2 functionalities, but I like to know whether they're there. PalmNum is a new one that came in on 7.1. And you can see it has a particular, gives you some examples. They're not the greatest examples, but they identify which parameter. What does it say? Returns the number of the parameter in the parameter list. The operand for PalmNum is the name of a parameter defined as part of the previous interface. So you can say PalmNum company number. The result of that would be a 1 because it's the first parameter in the interface. It's to allow you to find out which parameter is being used, which is the parameter number if you've got omits. So if you look at city name and you ask for the Palm number and it says 2, it means that the error code has been omitted because that is an omit variable. It's added. So reallocate storage. That was the heap storage that I discussed last week around using the heap storage as your user space. And that is a reallocation. You can change, if you initially allocate X bytes, you can reallocate it, you can resize it to make it bigger or smaller. I'm just looking here. The maximum allowed is about 4 terabytes, it looks like, or 16 meg. If the module uses TerraSpace heap, you can get 4 terabytes out of it. So please do me a favor. REM is getting reminders. That's nothing new there. Scan and replace. That was new in 7.1. I still to this day do not understand why it took RPG so long to get a scan and replace. That's a 7.1 function. We've had a scan forever, but scan and replace we haven't had until 7.1. Shutdown. By the way, this shutdown indicator, percentage shutdown is a useful function for background programs that run continuously. And each cycle of that background program, you should test the shutdown indicator via a percentage shutdown built-in function. If it returns a 1, what means is that the system operator or an authorized person has actually requested a controlled end on the subsystem. And that means that this program can respond to a controlled subsystem end and close down properly and under control without actually crashing because somebody has closed down the subsystem. So it's quite a useful built-in function. Size of something in bytes, there's nothing new there. Square root, I wonder whether anybody has ever used the square root function. Status. Go through these and see whether there are any that you can use. You can use a lot of these to convert your numeric dates and times or timestamps, either numeric or characters. You can actually use them to convert to actual date time formats in your files, which is something you should be considering as part and parcel of your of your modernization process. Opcodes, I wouldn't think. Remember, when you're using free form, there are a lot of these opcodes that you actually don't have to specify. Definitely speaking, the call B, call P, those you don't have to specify. The evals, you don't have to specify. So there are a lot of these that you can leave out of your code, and it creates a much tidier situation. Again, it's a good idea to go through these and see whether they've got any bars or hashes against them, and pick up any new functionality that there might be in these opcodes. Because you need, if you want to modernize your code, you've got to continually moving towards using the newer functionality of the opcodes, regardless of what they are. You need to be aware of them. On error, nothing there. Open. Sorry. Okay, Kay has asked me whether if you have to pull in data from a file, does it benefit you to use a user index or just use a logical? Oh boy, that is really a difficult question to answer. If you want to pull in multiple records from a file, it depends on what you want to use them for. If you want to store them and transfer them in a different sequence to another part of the job, maybe a user index is not a bad way to go. If you have a logical, you can use a logical, because using an existing logical to read a set of records is probably the fastest way to do it if the logical exists. Or you could also use embedded SQL and do a select something from. If you wanted to select a set of records in a particular sequence based on a particular selection criteria. So, okay, that one is almost an impossible question to answer. You're going to have to look at the entire context and then decide on which is the most appropriate method to do. Obviously, you want it to be simple, you want it to be fast, and you want it to be easy to maintain, and most of all, you want it to work properly and easily. This is a case of you've got to decide whether you've got a nail or a screw and what you're going to do with it. Okay. So your built-in functions, your opcodes, and all of that sort of thing, you must make a habit of every release. And I would suggest that you actually go through them. If you haven't done so for your current release, go through them and just familiarize yourself with what's available in these, in that particular operations and expressions and functions. All right, so that is the built-in function and other operations. And really, most of you probably using them already. I'm not going to go through each one and explain them because that's going to be a waste of time. But it's a good idea to review them on a regular basis. All right, let me... I've just got to find... right. I take it there are no questions about that. Okay. What does that lead me to? I'm going to just take that out of there, and I'm going to bring me back in. Right, I've got 10 minutes. I'm just going to very briefly. No, in fact, I'm not. I have 2 small topics, and I have 1 session right at the end of the session. So let's just, I'm not sure why we haven't got all the people in today. I wonder whether they got confused about whether the session was actually on or not. I'm going to actually send out an email to everybody so that they can at least listen to this session. The next 4 sessions are going to belong to Nathan Andelin, and he's going to actually take you through the tool that he himself created together with Kendall to create graphical user front ends for RPG applications. I'm not going to spoil his thunder, but it's magic stuff, and it's well worthwhile considering it, because that is the other part of the modernization process, is getting your front end to look a little decent. You know, like, people enjoy the graphical side of things. So if you can modernize your database and your code and your front end as a process altogether, you're going to end up with a very modern system. And that's what the next 4 sessions are going to be. Nathan is going to take the little customer master database that we created with the invoices and the products and the rep codes and so on and so forth, with their triggers and IO servers, and he's going to build a front end for that and show you how you can do it very simply. And if you want it just to be graphical, you can use the basic layouts. If you want it to be fancy, there's ways of making it very fancy. So that is going to be 4 sessions. Then there's going to be 1 session by a company called VR Tech. They have a product which we want to also include as part of AO, which allows you to link documents to particular people or products or records within your database. It's not, I would lie if I went into any more detail, but it's a way of modernizing the way you store and link documents. So they will have 1 session, and then the final session, which will be after that, you'll have me back again, and we'll do a complete wrap-up. So you'll have some time to think about the whole modernization scenario, both of database and the RPG code that I've been talking about for weeks. And please, that's the session where you need to send as many questions to me as possible. Anything that occurs to you that you might have tried and failed, or tried and had difficulty, or need some answers before trying it, that's the session that we need to take and deal with these things. So thank you. If there are any questions from this session, please send me an email. Otherwise, we will see you on Thursday for a complete change of pace and a change of topic. So thanks a lot, guys. And we will have to see if we can get a full team in on Thursday. Thanks. Have a great day.